Hello everyone, I'm Evan from Relearn to Share. Today is our third class of Precalculus and first class of Polynomial Functions. So in the next three classes, including today, we are going to learn about polynomial functions. So today, in the first class of polynomial functions, we are going to learn about polynomial functions and linear functions. Let's see the polynomial functions first. Polynomial function is a function f of x, and we can write it as a sub n times x to the power of n plus a sub n minus 1 times x to the power of n minus 1 plus plus a sub 1 x plus a sub 0. And here a sub n can't be 0. So as you can see here, n should be positive integer and a sub n is coefficient of x. And also a sub 0, which is equal to a sub 0 times x to the power of 0. And here x to the power of 0 is always equal to 1. So if a function be a polynomial function, then exponent of x should be a positive integer. So now, I think we can do some practice to judge which function is a polynomial function. You can do it by yourself first. Okay, if you're done, let's do it together. First one is f of x is x to the first power plus 2x cubed and plus 0.3 root x. So you can see here there is root in the function, which means it is not a polynomial function. So now let's see the second one. It is x cubed plus 5 over x. Because x is in the denominator, so we know this is not a polynomial function. So in number 3, f of x is 4x to the 5th power plus 3x squared minus 1 over 2x. So it's obvious that this function is polynomial function, right? Because its exponents are all positive integer. Now let's see another concept, binomial theorem. This is x plus y to the nth power is equal to n choose 0 times x to the power of n times y to the power 0 plus n choose 1 times x to the power of n minus 1 times y plus plus n choose n minus 1 times x times y to the power of n minus 1 plus n choose n times x to the power of 0 times y to the power of n. And n choose r is arranged in a triangle pattern in which the rows correspond to successive values of n, starting with n equal to 0, and this triangle is called Pascal's triangle. So we can draw this Pascal's triangle like this. So in the row of n equal to 0, it's 0 choose 0. In the row of n equal to 1, it's 1 choose 1 and 1 choose 1. 1 choose 0 and 1 choose 1. And in the row of n equal to 2, it's 2 choose 0, 2 choose 1, and 2 choose 2. And row of n equal to 3, it's 3 choose 0, 3 choose 1, 3 choose 2, and 3 choose 3. And in the row of n equal to 4, it's 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, and 4 choose 4, and so on. So in the Pascal's triangle, after 1, each number is the sum of two numbers directly above it. So in this triangle, the values are 1, 1 and 1, 1, 2 and 1, 1, 3, 3 and 1, 1, 4, 6, 4 and 1. So we know that here 2 is addition of these 1s, and 3 is addition of 1 and 2, and 4 is addition of 1 and 3, and 6 is addition of 3 and 3. So we can predict in the row of n equal to 5, it must be 1, 5, 10, 10, 5 and 1. So which are equal to 5 choose 0, 5 choose 1, 5 choose 2, 5 choose 3, 5 choose 4, and 5 choose 5. Now let's do some practice here. You can pause this video and do it by yourself first. Okay, first one is x plus y to the 5th power. So let's follow this formula. So it must be 5 choose 0 times x to the power of 5 plus 5 choose 1 times x to the power of 4 times y plus 5 choose 2 times x cubed times y squared plus 5 choose 3 times x squared times y cubed plus 5 choose 4 times x times y to the 4th power plus 5 choose 5 times y to the 5th power. So we calculate this one will be like x to the 5th power plus 5x to the 4th power cubed power y times y plus 10x cubed times y squared plus 10x squared times y cubed plus 5x times y to the 4th power plus y to the 5th power. Now let's see the second one. So this is 2x plus 3y to the 4th power. So it must look like 4c0 2 times 2x to the 4th power plus 4 choose 1 times 2x cubed times 3y plus 4 choose 2 times 2x squared times 3y squared plus 4 choose 3 times 2x times 3y cubed plus 4 choose 4 times 3y to the 4th power. So when we calculate this one, it must be like 16x to the 4th power plus 96x cubed y plus 216x squared y squared plus 216x y cubed plus 81y to the 4th power. This is easy but quite complex to calculate it. Yeah, so now we're going to proceed to linear functions. When we talk about linear functions, then the linear function f of x is mx plus b. Yeah, this one is the most popular form of linear functions. So in here, m and b is real number. So we should check, because it's function, we should check its domain and codomain. So this domain and codomain are all real number, just real number. And in coordinate system, the graph of the linear number, as you can see from the name, is a line, except for a vertical line. So we can draw this function y equal to mx plus b like this, for example. And the y-intercept, which is f of 0, is equal to b. So this point is 0, b. And x-intercept is minus b over m, 0. Yeah, this is x when mx plus b equal to 0. So now we are going to find the slope of this line. Actually, the definition of slope is difference of y over difference of x. So I can write down slope as delta y over delta x, which equals to y2 minus y1 over x2 minus x1. And this value of slope is equal to m. So when m is equal to 0, f is a constant function, and the graph is a horizontal line. And if you ask me how to draw a vertical line, then vertical line it will look like x equal to a constant. So we can say this is a function about whose variable is x. Yeah, so we can represent to this as a linear functions, but you can say it's a kind of equation of lines. Now let's see the way to representing linear functions. There are 3 ways to represent it. First one is ax plus by is equal to c. This is originated from the equations with 2 variables. So when we see an equation look like this, we can find this graph by this way. And second one is y equal to mx plus b. This is what we saw above. This is most used expression of linear functions. So when we have slope and y-intercept, then we can represent the linear function in this way. And the last one is x over a plus y over b is equal to 1. And a is x-intercept and b is y-intercept. So when we have x and y-intercept, then we can find the expression of linear functions. So as you can see here, if we have 2 points and there's a condition that this function is a linear function, then we can find this linear function too, because slope is when you subtract 2 points, then you can get its slope. So yeah, when we have two points, then it's really easy to get the function of the expression of linear functions. So yeah, we are going to do some practice here. So you can pause this video and do it by yourself first. If you're done, and let's do it together. So in number 3, there's a linear function that y equal to negative x plus 3. So yeah, we have to draw this function, and we can find the f of 0 first. Yeah, it's the easiest one. So f of 0 is y-intercept, which is equal to b. So in this function, this value is 3. So we draw this point 0, 3 here. Of course, we can find when x value when y is equal to 0. So when y is equal to 0, then negative x plus 3 is equal to 0. So this point we can find as 3, 0. So we draw 0, 3 and 3, 0 in this graph and connect these points with a straight line. So this is the graph of this function, my negative x plus 3. So now let's proceed to number 4. When the linear function f of 2 is 3 and f of 5 is 9, so let's find f of 6 together. And there are two solutions to solve this problem. So solution 1, because it is linear function, so we can write a system of equations. So 3, so when we say this linear function is y equal to mx plus b, then here 3 is 2m plus b and 9 is 5m plus b. So you can find m first. So m is 2 and b is negative 1. So when we calculate f of 6 here, so 2 times 6 minus 1, so this is 11. And let's see the solution 2. Because we have 2 points here, so its slope must be 9 minus 3 over 5 minus 3, which is equal to 6 over 3, so it's 2. So and here this is it can be equal to f of 6 minus f of 5 over 6 minus 5, because it's also another expression for its slope. So y minus 9 over 1 is equal to 2. So we can say y is equal to 11. Okay, it's easy, right? Actually, linear function is one of the easiest function in polynomial function, but it's one of the hardest, because when you learn the further chapters like in trigonometry, vectors and metrics, then we can learn another way to operate this function. So it will be very interesting. So yeah, today was first class of polynomial functions. Yeah, I think you may have learned today's lesson when you are in 8th or 9th grade or 10th grade. Yeah. So yeah, however, I hope you learned something from this class and it helps you to review linear functions and enjoy this class. And if you're interested in further classes, then please like and subscribe. And if you have any questions, then please leave a comment so that I can answer you. Then I will see you in the next class. Bye.